Hello and welcome. Today we're going to be understanding what is a relation. For us to understand what a relation is, I'm going to be considering two sets, A, which is 1, 2 and 3, and I'm going to consider another set, say B, which is 4, 5 and 6. Okay, now let me consider the Cartesian product or the cross product between two sets, which is A cross B. The cross product or the Cartesian product between two sets is going to be 1, 4, 1, 5, 1, 6. These are the set of ordered pairs where the first element of the ordered pair is from the first set and the second element of the ordered pair is from the second set. So going further, I have 2, 4, 2, 5, 2, 6, and 3, 4, 3, 5, and 3, 6. Now these are the ordered pairs belonging to this particular Cartesian product A cross B. Now let us also understand that this set A has 3 elements in it, and this set A B also has 3 elements in it. So the Cartesian product has how many elements? These ordered pairs are considered to be the elements of the set, isn't it? Because this by itself is a set. So the number of elements is 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 3 into 3. So the number of elements in A cross B is 3 cross 3, 3 into 3, which is 9. Now what I'm going to do is I'm going to be considering ordered pairs from the Cartesian product A cross B or A comma B in such a way or in such a fashion that the second element is going to be twice or 2 more than the first element. Okay, so let's see what are the ordered pairs which satisfies this condition. I can see that 2, 4 satisfies the condition, so does 3, 5. These two ordered pairs satisfy this condition. And what is this condition? This condition is called as a relation. Okay, so what is a relation? A relation is simply a correspondence or a connection or a way to connect the first element to the second element of the ordered pair from the Cartesian product of two sets. Okay, so the relationship R is generally written like this: ordered pairs A comma B, where B, the second element, is 2 more than the first element, where A is belonging to the set A and B is belonging to capital B. Okay, now again the ordered pairs which satisfies this condition was 2, 4 and 3, 5. So if you want to look at this on an arrow diagram, it's simply like this. The first set, let's go back and look at the first set, had 1, 2 and 3, and the second set had 4, 5 and 6. So I'm going to write that 1, 2, 3, and then I have a 4, 5 and a 6. So I saw that 2 was related to 4, or 2 was corresponding to 4, and 3 was related to 5. And this is the arrow diagram of representing the same relationship. Okay, now to talk about relations on two sets, well, I explained a relation as a subset of a cross product, isn't it? That's what a relation is actually. A relation is basically the subset of A cross B. Okay, it's simply a subset of A cross B. Now, how many subsets can I form here? Any guesses? Well, it's going to be 2 to the power of 9. For people who do not know why, I'm going to do a small explanation for you. Let's say I have a set A, which is A, B and C. Okay, now I'm going to write all the possible subsets of this particular set. Okay, let me start with a B. First, I'm going to take all the single elements, which is, this set is called as a singleton set. If you remember, it's a set with one element only, so it's called as a singleton set. Now C, and then I have D, which is C, and then E, which is simply going to be A comma B, and F. Let me take that as A comma C, and E F G, which is B comma C, and I have another set H, which is a set itself, which is A comma B comma C, and then I have the null set. Okay, great. So how many subsets do I have? This had 3 elements, and the number of subsets is 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. So if I had 3 elements, then the number of subsets is 2 to the power of 3, which is 8. Similarly, if I had 4 elements in the set, then the number of subsets will be 2 to the power of 4. Isn't it? Now let's come back to this. If a relation is supposed to be a subset of A cross B, then how many relations can I define on this particular set from A to B? From A to B, any guesses? Well, that's going to be 2 to the power of 9. That is the number of subsets that a particular set can have, or A cross B can have, isn't it? So that's the basic understanding of what is a relation. Okay. Let me define one more relation for you. Let me take a set A defined as 1, 2, and 3, and I'm going to consider another set, let's say B, which is 4, 5, and 6. Okay, I'm going to change the color of the ink. I think I'm going to choose this. Okay, so I'm now going to define a relationship R. I'm going to be picking up order pairs x, y, such that x divides y. X is completely dividing y. This relationship in mathematics can be written like this: x divides y. That means divides by. So in this case, this is such that, and this is x divides y. So what I'll do is I'll give a small change to this. I'll modify this. I'm going to write this over here, and I'm going to erase this to write this such that x divides y. Okay, great. Now, what are the order pairs that's going to be satisfying this condition? I'm talking about a relationship from A to B. So this is going to be such that x belongs to A and y belongs to B. Okay, now it is clear to me that the relationship has been defined from A to B. Okay, we'll have to logically think about it. So x is dividing y, which means the remainder is 0, whereas it will have a quotient, but the remainder is going to be a 0. We know that 1 divides every other element, isn't it? Yeah, 1 will divide every other element. So I'm going to pick that up. 1, 4, 1, 5, and 1, 6, and 2 divides 4, so I'm going to pick 2, 4. 2 also divides 6, so 2, 6, and 3 doesn't divide 4, 5, it divides 6, 3, 6. Now this is the order pair belonging to this particular relationship R, defined in such and such way. We will now look at this in the arrow diagram. This is my first set, and this is my second set, A, and this is my B. Let's see what are the elements of A. Let's go back and look at that. 1, 2, and 3, and 4, 5, and 6. Okay, that's very simple. 1, 2, and 3, and then I have a 4, 5, and a 6. Okay, here if I'm looking at this, 1 is corresponding to 4, 1 is also corresponding to 5, 1 is also corresponding to 6. I'm going to change the ink here for the second element. 2 is corresponding to 4, and 2 is corresponding to 6, and then I'm going to change the ink once again. 3 will correspond to 3 alone, 6 alone. Okay, so now we're going to define something known as a domain and the codomain and the range of a relationship R. Okay, the domain of this particular relationship R is simply the element which is belonging to the first set and to the relationship R. Okay, basically if I'm looking at the connections here made by the lines, I'm talking about the elements which is connected to some element in B. So my domain is simply going to be 1, 2 and 3. And what's my range? In this case the range is 4, 5 and 6. And what is my codomain? My codomain is the entire set B, which is actually 4, 5 and 6. Okay, now I'm going to pick up a different example and explain to you what is a range domain and a codomain. Let's say for some reason I had a set A here and a set B here. Okay, now A is connecting to B under the relationship R. I don't know what the relationship is. I'm just trying to explain the domain, range and the codomain part of it for you. Okay, so I've taken 1, 2, 3, 4, 5, 6. Here I'm going to write A, B, C, D, E, F. Okay, that should be fine. Now let's say under some relationship R, 1 was connected to C, okay, and 2 was connected to B, and 3 was also connected to B, 4 was connected to A, 5 was connected to C, and that's it. Okay, so this is a relationship that I'm going to be considering. This is a relationship that I'm going to be considering, or the correspondence that I'm going to be considering. So in this case what happens is all these elements, the ones which are connected only, these are my domain, and the elements in the second set which are connected only are my range. Okay, and the entire set B will be called as my codomain. You're understanding? And the 6 is left out. There's nothing that we do with 6. It's just left out there. So we now have a clear understanding of what's a domain, what's a range, and what is my codomain. Got it? Let's now look at set A, which is given to me as 1, 2 and 3, and I have another set B which is given to me as 4, 5 and 6. 4, 5 and 6. Okay, now I'm going to be writing a relationship R in terms of the ordered pairs. Let's say 1, 4, 1, 5, 1, 4, 1, 5. Then I have 3, 6, 3, 6, 2, 6, and a 3, 4. So this is my relationship. So the question here is this a relation from A to B? If yes, why? It is a relation because the first elements of the order pairs are all from the first set, isn't it? They are all from the first set, A. And the second element of the order pair are all from the second set. 4, 5 and 6. This is 6. 4 belongs to B. So what is the domain in this case? Can you tell me what's the domain in this case? It's a 1, 2 and a 3. That's my domain. And what is my range? My range is going to be 4, 5 and a 6. It's the entire set B. Okay, and the codomain is simply the B set or the second set. With that being said, I think we have now clearly understood what's a relation. Okay, the next few videos I have talked about the different types of relation that we have, and how do we deal with the relations, and how do we go about finding the inverse of a relation, and so on and so forth. Okay, thank you very much. Please advise your friends to go through these videos and subscribe to the same thing. And if in case you need a few things to be changed, or if you feel that the videos can be upgraded in a certain way, please do leave a comment about it. And even if you like it, I would appreciate if you can leave a comment on the comment section for this particular video. Thank you.